Dear all, I hope all are doing good. So here we are again going further on as we have discussed last class. We are going further more on deep learning techniques, different techniques used in deep learning. So already we discussed some part of transfer learning, some introductory part of transfer learning. So in this video, we are going to see really what is happening inside transfer learning, what are the advantages of transfer learning, and which are the architectures used, what is the application, etc., and what advantage we are going to get if we are using transfer learning. Okay, so from the name itself, transfer learning means what? You are understanding that we are transferring the learning. These are the contents of this unit. Transfer learning in machine learning, deep learning and image classification topologies like LANET, AlexNet, VGG. LANET and AlexNet you have already learned. So VGG we are going to learn the next class. Then Inception, ResNet, GoogleNet, etc. Again we are going to see introduction to recurrent neural networks. Already you have seen. Okay. So the here transfer learning. So transfer learning means we are transferring some learning from somewhere to another. Okay, the study of transfer learning is motivation. I mean, what motivated? By the fact that people can intelligently apply knowledge learned previously to solve new problems faster or better. See, I mean, in our day-to-day life, the equations you have learned in your 7th class, 8th class, etc., you are using right now for your mathematics, right? Addition, subtraction, LCM, HCM, HCF, etc. Equation when you have learned you have learned it long back, but you are using its application or that knowledge you are using here. Similarly, Einstein's law, E equal to mc square, all those equations in physics you have learned all those supercapacitors, etc., and the applications you are going to learn in semiconductor devices or in another kind of in another like physics or something. If you are going further, you can transfer that knowledge to here. So basically the same logic applied here also. So transfer learning, I mean transfer learning, what is this picture says? If you are traveling on top of the car with a cycle, you are not cycling, actually you are on the top of the car, so actually you will get the speed of the car, that is you have transferred that knowledge. So this is something that technically speaking in transfer learning, the knowledge of an already trained machine learning model is applied to a different application. For example, if we are taking a simple classifier for whether an image contains a backpack or whether an image contains a cat or dog, you could use the knowledge that the model gained during its training to recognize other objects like sunglasses. Okay, I mean, it's nothing but, see, now we are talking about neural networks, right? Convolutional neural networks. So convolutional neural networks are having several layers: layer 1, layer 2, layer 3, flattening layer, softmax layer, and the finally will be the fully connected layer. What is the difference between, one of the difference between machine learning and deep learning? In machine learning, we are extracting the features of the objects and then we are feeding it into the classifier. But in convolutional neural network, the features, the best features to categorize or to classify it itself. Okay, this convolutional neural network itself extracting. Okay, it itself extracting. So you no need to do any feature extraction. So what will happen in transfer learning? Already during training, the algorithms have learned some features, and that algorithm, that model is used for classification of another thing. For example, animal classification. We wanted to classify in an image whether there is a cat, there is a dog, and there is a duck. Okay, but the same thing we can use for the identification of sunglasses, objects, chair, tables, etc. How? Because initial layer weights and parameters, there are many hyperparameters, many weights and biases are there. So the initial weights and initial parameters we are not going to change. All those parameters as such will continue for this classification. That is, Our first problem in, we have two problems. First problem in hand will be the identification of animals. Second problem in hand will be the identification of like tables, chairs, etc. So what will happen? The initial layers in for both the problems, initial layers will be taking only the edge features, like I mean edge factors, like yeah, if we are taking some corner features, okay, this corner features is applicable directly. The weights that are used for these corner features or the initial features, it will be taking as such for the another problem also. Okay, but the final layer we are going to tune, or we are going to hyper tuning, fine tuning, that is called as fine tuning. Fine tuning matlab we are again training. So no need to train from the scratch. We are taking already learned model, and we are just changing the final layers, fully connected layers, and before final layer, which are the stem layers, that we are going to fine tune and we are going to change it. Okay. So CNN is used as a fixed feature extractor. So what will happen? Take a, this we have, I have already told. Take a pre-trained CNN architecture on a large data set. Remove the last fully connected layer of this pre-trained network, and this fully connected layer we are going to train for the new data set. Okay. So this is the transfer learning. So layer 1 as such we are going to use. Then layer 1 का layer 1 के बाद layer 2 आएगा, layer 3 आएगा, layer 4 आएगा, layer 4 के बाद layer 5 आएगा. इसमें last जो stem layers will be there, that stem layers we are going to tune according to the new data set. Okay. So lower layers generate more general features. That's why I said it will be corner features, edge features, etc. Knowledge transfers very well. We can apply to the other task. Higher layers are more task specific according to more our data set specific. So fine tuning, sorry, tuning spelling is incorrect here. Tuning is Tuning. Sorry for that trouble. Okay, not that. Fine tuning improves generalization when sufficient examples are available. Sufficient examples matlab, if we are having a large data set and we are having a smaller data set, and if we want to do the same convolutional etc for the small data set, we can use this transfer learning, and it often leads to the better performance than training from the scratch. Okay, even features transferred from distant tasks often perform better than random initial weights, correct? Because if we are training from the scratch, we have to initialize randomly about the weights. But if we are transferring the knowledge already, it has performed well on some other task. And we are taking that. ImageNet is a very well architecture for transfer learning. Okay. So the same thing. Then what are the advantages of transfer learning? These are same thing we have already discussed. That's why I skipped. Advantages is what? Saving training time. Obviously, because we are not going to start from the scratch. Better performance of neural networks. Because why? Because random weight initialization is not here. Okay, not needing a lot of data. That is also again because if we are comparing machine learning and deep learning requires more data. Convolutional neural network requires larger data set for training. So, if the problem in hand matlab हमारा problem right now, what is the problem? Problem is what is the task we need to do. If that task contains lesser data set, there is no need of going for data augmentation or any other purposes. We can directly, I mean, it is another option of transfer learning. Then this is transfer learning. If we apply transfer learning for this task, which one? Audio signal is there and speech recognition is there. So if we are applying this transfer learning for this, then what happens? And below you can see that all the initial layers as such we used, at the last the final fully connected layer we have converted and we have fine tuned it for our present task. What is that? Watermark or typeset detection. Okay. Then the popular CNN that are used for transfer learning are LayNet, AlexNet, VGGNet, ResNet, etc. इसमें ImageNet having the highest accuracy for this transfer learning. These are some of the other algorithms. That's it. So how this transfer learning happens and hands-on experience on this transfer learning, that we will going to see in the next class. That we will be in one-to-one in MS Teams. So we will see in the next class. Thank you.